Greetings! My name is Matthew, and in this video we're going to talk about properties of logarithms. The first one of the properties is called the product rule, and what the product rule allows us to do is when we have a logarithm that contains a product like m times n, we can expand that logarithm and give each one of the two factors, in this case, two factors m and n, each one of them kind of gets their own logarithm. You'll notice that on the left and right hand sides of the equation, we have a base of b in all three of these logs, one on the left, two on the right. And on the right, the new logarithms are separated by a plus sign. So it's as though multiplication, which is a product, sort of turns into addition in a way. All right, so we can use the product rule to expand a logarithm like this one. Log base 9 of 9x turns into log base 9 of 9 plus log base 9 of x. In this case, we can take this one step further and we can simplify, because as we talked about in the previous section or the previous video, the log base 9 of 9 can be evaluated because 9 to some particular power equals 9. 9 to what power equals 9? The answer is 1. But there's nothing we can do to simplify the log base 9 of x, so we're stuck with that one. This would be our most simplified answer. The product rule involves taking multiplication and sort of turning it into addition. No surprise that the quotient rule involves division, which kind of turns into subtraction. Log base b on the left, log base b on the right. The thing in the numerator got its own logarithm. The thing in the denominator comes after the minus sign. So here's the n in this denominator, and there's a minus log base b of n. And we're going to find in the next sort of few minutes here that if there were a couple of things in the denominator, they would each lead with a minus sign before their logarithm. So if it's a negative log, it came from the denominator. I think I can safely say it that way. So let's use the quotient rule to expand this logarithm. We have log base 5 of 25 over z. That's equal to log base 5. Now notice, this doesn't say negative log base 5, it says positive log base 5. So what I'm going to put here comes from the numerator, which is a 25. Now I'm going to write minus log base 5, and since it leads with a minus sign right here, what goes in as its argument is the thing from the denominator, which in this case is a z. Can we simplify either one of these logarithmic statements any further? Absolutely. The log base 5 of 25 can be simplified because 5 to some power is equal to 25. And that would be 5 to the second power equals 25. Nothing we can do with log base 5 of z, so we are, as I say, stuck with that. Log base 5 of z. And that, ladies and gentlemen, is your final answer. So we simplify as much as we can. So that's option B, as in bravo. There is a third rule called the power rule. Logarithms have these. Exponents have these. If you study calculus, even like a business calculus class, you're going to find out that derivatives have a product rule, quotient rule, power rule. So these kinds of things, these three rules in particular, sneak into all sorts of little sub-studies of mathematics. And what we see happening here is on both sides of the equation we have log base b, so the base is consistent. On the left-hand side of the equation, we're taking the log base b of m to the power of p. Let me change the size of this. There we go. Oops, I went too far. There we go. And there we go. So this maybe makes it a little bit more clear that the p that was previously in the exponent position has now moved out in front of the logarithm, to the left of the logarithm, like a coefficient. And in fact, that's what it is. If the p-value were a 5, it would have gone from being an exponent of 5 to then a coefficient of 5. 5 times the log base b of m. Or in this case, on the right-hand side of the equation, p times log base b of m. So there is multiplication happening right there between the p and the log. And that's your power rule. And we can use that in order to simplify, or rather expand, this logarithm. In this case, it's equal to this 7 that's in the exponent position is going to come out front like a coefficient. So there's our 7. If you want to write a little multiplication dot in there, you can. It's not traditional to do that, but for the purposes of getting the hang of this, you may. Log base b of x. And that's it. We can't simplify that one any further. So just an illustration of how that exponent comes out front. There's a little summary of our 3 rules. And now let's apply them to this really gnarly looking logarithmic expression. We're going to do this in multiple steps using only these 3 rules, so hang tight. I think we can handle this. The biggest thing that I see happening here is I've got a fraction. And a fraction has a numerator and a denominator. So that's how I'm going to start to expand this. I'm not going to expand the whole thing all in one go. I'm going to use my properties, my rules, one at a time. So the first thing I'll do is say that my original expression is equal to the natural log of the numerator, x to the 4th power times the square root of x squared plus 3. And then there's the denominator. It gets its own logarithm, but in order to illustrate that it came from the denominator, it's going to be a negative natural log of x plus 3 to the 5th. Okay. Something else that I think if you want to do this now or if you want to do it later, well, we could do it. Let's do it now. I'm going to change this square root symbol. I'm going to change it to be a power of 1/2. So I'm going to go in with my eraser here, take that out, and I'm going to give it its own set of parentheses so that I can raise just that portion to the 1/2 power. There's still multiplication happening here. If you want to put the dot in there, you can. Again, it's not typical to do that, but to make sure that you stay organized and know what's going on, if you need to do that, do it. Now what do we see? The next thing that I see is inside this natural log, I've got multiplication, and I've got a power and a power. And over here, there's nothing going on inside of these parentheses, but I do have a power out here. So I think what I'll do is just implement the power rule because of this multiplication that's happening here. So really, to go from our original expression to this one, we use the quotient rule. And then the next thing we're going to use is the product rule. And if you wanted to, you could write it like this. So that on the next line, we have equals the natural log of x to the fourth. Multiplication changes to addition, and this next factor right here gets its own natural log, or log base e. So the only thing that we changed was here by way of the product rule. I'm going to keep the minus natural log x plus 3 to the fifth. Okay, that natural log is not going to change. Minus natural log x plus 3 to the fifth. Okay, so now the only other thing that we can do in this problem is the power rule 3 times. So we're going to power rule here, power rule there, power rule everywhere. Not really everywhere. So the exponent comes out front like a coefficient, 4 times the natural log of x, plus bring the exponent out front, even though it's a fraction, doesn't matter, 1/2 times natural log. Keep your parentheses there so that the x squared plus 3 stays all bundled up. Good. Minus, bring the 5 out front. Now it says minus 5 times the natural log of, keep the parentheses around that x plus 3. Nice. All right, you have totally expanded that logarithm. That's as far as we can go. If there were some aspect of this that could be simplified, for example, if this said e to the 7th power, then we would simplify. Natural log of e to the 7th power would just become 7. Then you'd have 7 times 4, which is 28. But for the moment, this is as good as it gets. And then the next thing that we're going to look at is condensing logarithmic expressions. So exactly what we just did, we're going to apply these 3 rules, except we're going to take this already expanded statement and we're going to put it all back together and write it as one natural log. All right, sorry, I had a little technical difficulty there. So we're going to condense or consolidate this already expanded logarithmic expression. And I think that we can do this one almost exactly in reverse from the way that we did the previous one. Let's see. We're going to take this statement, and on our way to the next version of this expression, we're going to use the reverse power rule. The reverse part isn't really a technical term, but hi. Would you like to come say hello? Do you want to come say hi? We have a special guest. You want to come say hi? Come make a little cameo. Come here. Oh, yeah. Hi. This is Luna. Some of you have seen her before. Some not. What are you doing out there? You are a good girl. You are so fluffy. Do you know anything about logarithms? No? She's looking away. She wants nothing to do with them. All right. Go sleep somewhere. There you go. Reverse power rule says that we can take the coefficients and put them back into the exponent position. So let's do that. The 4 is going to go back up on the x. So we've got the natural log of x now to the 4th power. Plus the 7 is going to go back up to the exponent position. So the natural log of y to the 7th power. Minus the natural log of z. And the 3 goes back up there. All right, so now we've got all of our exponents back into the exponent position. What can we do next? I think that we should still continue doing this kind of reverse order from what we did previously. It just so happens, let's use the addition that's happening here, and we will do the reverse product rule. The addition is going to turn into multiplication. And we can write this as equaling the natural log of, and I'll put parentheses around this, x to the 4 times y to the 7. That's a 7, not a z. There we go. Minus the natural log of z to the 3rd. And then finally, we will reverse quotient rule. Anything that has a minus means that it came from the denominator. So equals the natural log of a fraction. If it's positive, it came from the numerator, so there is an invisible plus 1 or positive 1 in front of that natural log, so that tells me that the x to the 4th and the y to the 7, not z, it's a 7, to the 7 go on the top, and this negative again in front of this natural log says that z to the 3rd must have come from the denominator. If there were another minus natural log of p to the 2nd power, then we would introduce p to the 2nd power down here also, because again, if there's a negative sign in front of the natural log, that means that its argument, the z to the 3rd, the p to the 2, came from the denominator. If you would like to go back through and introduce that natural log of p squared all the way up, you can do that in order to make the problem just a little bit more complex. Just make sure that you also introduce this minus p squared right here also. That should say 3z. Oh, well, you could put the minus natural log p squared. Even better would be, let's see. Let's erase that, erase this, and you could put minus 2 natural log p. Minus 2 times the natural log of p. So if you'd like to include that to make the problem a little bit more complex, that's not a bad idea. And then this would be your final answer. Or everything that I wrote in red, forget it. And just do the stuff that I wrote in blue and you'll be all set. The change of base property is very handy when the base of a logarithm, if you're given a logarithm that has a base other than a base of 10 or a base of e, natural log, it might be handy to be able to change your base into either base 10 or base e. Why would that be handy? Why would that make the working on that problem more convenient? Because in your calculator, you only have 2 buttons that pertain to logarithms. There's the common base, which is base 10, and there's the natural base, base e, natural log. So on my graphing calculator in the left-hand column, I do have a natural log button and a log button. And on my scientific calculator, yep, up here in the top row, I've got a logarithm, a log button, and an ln for natural log button. And that's it. There's no log base 17 3/4, okay? So you might need to do a conversion. If that's the case, this is what you're going to need. This is a really nice test question because it's hit or miss. I give you, I or whoever your instructor is can give this to you, and either you studied it or you didn't. Either you committed it to memory or you didn't, but it was communicated to you, so now it's your responsibility to remember this thing. And you'll notice that just sort of match up these pieces. It's log base b, and now b has become an argument in the denominator on the right-hand side of the equal sign. The m was the argument over here, and the m is still the argument over here. I should have done those in a different color, maybe. There's the m, it's still an argument. And then this value of a, this new base, is just that, it's new. Well, what is a supposed to be? It can be whatever you want. So I could make it e so that I could write this whole thing as a natural log over a natural log. Absolutely. I could make it base 10 so I could use just the regular old log button on my calculator in order to evaluate an expression. Absolutely. So here you go. Here's where we're making the conversion to where you have a new base of 10. So we just write it as a log on the right-hand side of the equation. And here on the right-hand side of the equation, you see the ln for natural log because we have chosen to make our new base a base of e. So the lowercase a value from up here at the top of your screen, when we went this way, it became a 10 right here and right here. And when we split off and went this way to the right, it became a base of e right there and right there. Use common logarithms or natural logarithms on a calculator to evaluate 4 decimal places. This log base 16 of 57.2. Great, I'm going to use natural log. I'm going to say that this is equal to the natural log of 57.2 over the natural log of 16. And then I'm going to go into my calculator. I'm going to do this in my graphing calculator first because it's just so easy to enter it. I'm going to hit the natural log button, 57.2, and then I'm going to close the parentheses because on my calculator, which is a TI 84 plus, when I hit the natural log button, it immediately automatically gave me a parenthesis. So it said ln parenthesis. So I typed in the 57.2 and then I closed my parentheses. And then I hit divided by, then the ln button again for natural log, 16, close parentheses, enter, and I got 1.4595 rounded. 1.4595. And we could put a squiggly equal sign there to indicate that this is an approximation. Let me see if I can get the same thing on my scientific calculator because doing everything on the scientific calculator is a pain in the neck. How do I type this into a TI-30XA, which I know at my school is the go-to calculator? First, I'm going to type, you might want to write this down. If you're using a the TI-30XA, you might want to write down these keystrokes. I'm going to type in 50, so hit clear a couple of times to make sure you're starting with a good 0. I'm going to type 57.2. Yeah, I'm typing 57.2 first. Then hit the natural log button. Then type 16 and hit the natural log button. Now, if you're following along, what you're seeing on your screen is 2.77 blah, blah, blah. That's just the natural log of 16. Now I'm going to hit the divided by button, and it's going to actually do the... Nothing happened. I got to start that over. I screwed up. 57.2 natural log. Oh, divided by 16 natural log. Right. So now that I've got 2.77 on my screen, blah, blah, blah. Now I have to hit the equal sign on the calculator. Hit that button. And on my screen now I see 1.4595 rounded. Oh, I got the same answer. Perfect. So a little unusual of how you have to type in the order of the keystrokes on a single line entry scientific calculator, but you can get the same answer. You just have to type it in the right order. So make sure you've got that down, and that is it. That is the end of this section. It has been such a pleasure showing you some of the properties of logarithms. Make sure you get that power rule, product rule, quotient rule down. The change of base should be free points if you run into it. It's free, F-R-E-E. That should be a super easy problem as long as you know how to do the change of base and know how to type it into the calculator. You can't answer those problems without a calculator, so don't forget your calculator if you're going to a quiz or a test where you have to do one of those problems. And definitely practice expanding and then condensing those logarithmic statements. Remember, if it's got a minus sign in front of the log, take the argument and put it into the denominator. Okay, that tells you that that's where it came from the denominator. All right, I'm going to go rest my voice. That's 5 videos in a row. Good times. Thanks for hanging with me. See you again.